Check, check. Hey, it's the 12th of March, 2025. This is All Things Go from Blink Labs, Gimbalabs, and friends. We get together on Wednesdays at 14:30 UTC to learn how to build in Go on Cardano. I mentioned the time, 14:30 UTC. All meetings at Gimbalabs are pegged to UTC time. So here in the United States, it is a different start time than it was last week. Hopefully that doesn't trip anybody up too much. And if you live elsewhere in the world and you're changing your clocks, say a couple weeks from now, just be ready. The start time of this meeting will change for you because we peg things to UTC time. So just want to say welcome and hand it off to the Professor Mix, who's going to help us build an agenda for today. How you doing?
I'm doing good. Thank you, James. And hello, everyone, and welcome to another session of All Things Go. Though we tend to keep things dear to ourselves, so we don't allow them to go. So yeah, today's what we want to keep it to ourselves. Talk about would come from you guys. So we had two sessions. We talk about the tools available in the whole current Go environment and space in Cardano, and then we look into kind of several tools, mostly looking into Dingo. And I think now it's a good step that we kind of looking back to the whole idea of someone we assume that does know Go, maybe other languages, but the person wants to get uh, their minds more into Cardano and of course blockchain and the whole these ideas and concepts that we were talking in actually the kind of last two sessions. So I'm going to recommend, actually, I'm suggesting now to let's create a meeting agenda for today. Sure, for future as well, if we have too many agenda. About what do you guys think that we need to talk as a concept, as an idea, what things that you need to know before starting to build or before starting, to just getting your hands dirty with Go specific tools. Like, for example, someone asked a question, or like well, I assume he shared the issue that he needed to, start doing that. And people say, hey, I have this question or that. So this can kind of comes an idea that he wants to know, okay, I have this need and I want to know how to approach it. So I wonder what would be your, actually, let me share this link so you guys can see it as well. But I wonder what would be yours. What do you want to discuss? What do you want to know? Like what kind of dark side or gray side in your mind hasn't been, just touched or discovered because of something doesn't make sense even to you. So if you have something, please paste it or comment it in the chat so I can add it in the meeting agenda, and then we can move forward and talk about it. But actually, let me
Sure,
start from Chris. Yeah.
I've got a good starting point, and
Yes. Yes.
I'm gonna oversimplify it with the main point, and then kind of get down, and that is time.
Time.
Time on
Yes,
Cardano.
blockchain
How
time.
time works. Not only that, but how it's changed, how the rules have changed, what eras are, what they mean, how they've progressed, right? All of that is actually super important in almost everything that we do. But we tend to not think about it until we start trying to teach someone new. And then suddenly you're like, oh, wow, yes, there's a whole bunch of random things that, aren't based on clock time. So,
Life doesn't feel short until you're dying,
you know,
basically.
or until you are submitted, kinda, to the next.
Until you're waiting for your
It's-
transaction to submit.
You're-
Yeah.
we call it
I mean,
limbo, but it's a mempool for human souls.
right. So, just to kind of go real quick on something that I'm planning on doing with my team on teaching them some of this stuff is I plan on showing, not necessarily in the Go context, but like just using a couple things in the ecosystem, decks or, like whatever, and showing them and then explaining to them everything that's actually happening through all the layers, right? As this seemingly simple interaction happens, right? It's like, oh, you go to a dex, you input, I want to buy this much of a token or whatever. You click OK, you sign, you submit. That seems pretty easy, but like, what actually all else is happening? So there's a lot of depth to what happens in the simplest of things, right? And then the other things kind of related to time, but not necessarily exactly the same thing would be like protocol parameters, both Genesis and the changing ones, and what in the heck those are even about.
Yeah, protocol parameters. Well, let's go. Should we go in the kind of a dark space of the protocol parameters as well, guys? What do I mean is the Genesis keys. Who holds them? What the hell is Genesis keys and
Yeah,
etc.
no, we don't need to go into anything political that
Okay.
has
That
no
doesn't make me
bearing
a better Go
whatsoever.
developer.
Yeah, it won't. So there's no reason to talk about it whatsoever.
Okay.
Other than the fact that you can talk about it from, how it matters to us, like as Go developers, for us, being able, cost models, what things are necessary out of the Genesis configs, how those things work in general, like what do they do? What do they mean? What does Genesis mean? Right. We have different networks, and just kind of like what are they? What is the purpose of different networks? And then so I mean, like, if you want to talk about Genesis keys and that sort of stuff, only in the abstract of bootstrapping a network, right? And this is something that, talking about Dingo, this is something we're currently looking at is calculating and storing the pots, right, that start off from the very beginning, from Genesis. Where does the initial Genesis money go? And that sort of thing. And so we're starting to, like, write that support into Dingo and calculating that stuff. But I mean, so it's not necessarily super important to go to that depth on it. But as far as using them for calculating things like time, right? The Genesis configs play a big role in how time is calculated. And then they're the starting point for protocol parameters for all of our cost models, et cetera, right? And while they are mutable, that's the sense I would put them in, is essentially what we need for transaction building or for something actually interacting with the chain, not necessarily concept of like who holds them, right?
So I'm trying to coming up with that kind of question that what are the relationship of all above to building a project or library or a code base kind of. What is what are actually not is because I suspect it is. So anything else, guys? I know it's a lot already, but I wonder any other people that do they have anything in their mind or something that they want to us to talk about, maybe related to some of these concepts and ideas and question, as Chris mentioned, and you have something that, for example, for time, we might you might later see something about the script validation, about like what does this script validation for time means, like what is POSIX times or etc. So yeah, I think if you have any, please share it in the chat. I'm going to add it, but I think we have
I
great
added
set of.
that one below when Chris was talking about DEXs because it's not really related to how the protocol handles time, but it is related to how an app handles time. Yeah, how do you handle
Yeah.
like UTXO contention, right? If two people are trying to build a transaction drawing from the same UTXO and a DEX, I think that's a really that's Go expertise that would be really interesting to look at together, best practices, while highlighting the reason this is an issue from a Cardano perspective.
Yep. So, sure, we have all these, and I can say that first. I just said in the chat. Um, you, I like to know about the Plutus PBL 2025 course.
We got you, partner. Yeah. We're gonna launch it soon. We're putting finishing touches on those fixes, and we promise to make some noise about it on the Gimbalabs Discord, on the Gimbalabs Twitter, and we'll put up some Reddit messages about it too to make sure you know about it. But it's almost ready and coming soon. Can't wait.
Great. So time. Well, the easy answer, actually, I learned this from Chris, is time is really sucks in Cardano. It is not, although the advertisement or propaganda was time is really deterministic, but it is, but a portion of the time in Cardano, no, it is not. For example, well, I think we already, I mean, maybe some of us heard that each 20 seconds, and I wonder where do we have these resources about that? For generating each block, like Cardano generates each block 20 seconds, but that's not accurate. 20 seconds is kind of the average. So for generating, like for example, in Bitcoin is different, in Ethereum different. I mean, you guys, I think maybe heard that. If not, block producing by nodes or by validators has a time limit. It is not like you can just waiting until, for example, 100 transaction comes and then you generate your blocks. Sure, there is a limitation on that transaction numbers and the size, but there is also the limitation of time as well. So a block might have one transaction, another block might have 1,000 transactions inside it. Maybe assume that it can contain all of this. And that I kind of creates all sort of bunch of problems as well, which we will go and look into it. And why not? I'm not seeing here. Maybe I should refresh it. So yeah, okay. So I wonder where do we can find the time in Cardano? I don't know, maybe CDDL somewhere that we can look into it in Cardano Ledger. Maybe, I mean, the best place normally is for looking into the core of the stuff, right? And here in Cardano Ledger, which is where all these times talk about, happen here. But actually, maybe, I mean, let me share this link as well. By the way, we are at this era, just making sure we are, we are at this era, Conway. But yeah, before starting, what is era? Well, I can kind of say that era is referring to big changes to the nodes, aka hard fork, or maybe several hard fork. But as far as I know, maybe you guys can correct me as well. As far as I know, each era started and finished by a hard fork, and by a hard fork, I mean that we have a Cardano node here or Cardano ledger here. It has set of rules and set of codes, and it's like a release. Okay, it's kind of a release, and once you have this major release in the blockchain terminology, we call it hard fork, which means once you have this major release, the things comes after that are not really compatible. I mean, it is not necessarily compatible. It might be compatible, but it is not necessarily compatible with what came before of this release, hard fork, etc. So you guys might know about the releases. We have major release, we have minor release, etc. In the blockchain, not just Cardano terminology, we call this major release, which has the compatibility issue, hard fork, and the one that doesn't have compatibility issue, or at least it's very, very minor. Probably, for example, in your Cardano node, you have to increase your, I don't know, like hard drive or RAM or whatever. They call it soft fork. So yeah, Cardano node, and here we can see in the release. So these release, like you can say, okay, minimum system requirement like 24 gigabyte of RAM, and let's say for some reason we wanted to give more computation power to the nodes for whatever, like we will talk about, like transaction validation. That might be considered a soft fork, or AKA minor release, and it is not an error. It is just maybe we can call it. I mean, I've seen that we name them. So like we had this Valentine software. We had these like we used to name things, and we like naming things, making them important. So yeah, those are not error, but the errors mostly refers to these major releases, which we introduce major changes. And by major changes, for example, Bluetooth version 2, Bluetooth version 3, governance, or decentralization of these treasury, or voting, etc. So yeah, I mean, these are errors, and because of those major things is going to happen, we need, beforehand, we need to know how things are going to work, so that the people who are working on the tools, especially in the Golang tools, if you have a project, if you are writing something, or you've already written something and you want to be compatible, you want to be updated, you have to go through these standards, so that you won't get surprises, at least. Sure, things are not going to be really easy at least, because one of the big problem is all things mostly in Cardano are written in Haskell. I mean, the fundamentals. So going through the codes, reading to figure it out, sure, it's could be difficult. But normally, if you go through the errors, and I mean Cardano ledger errors, and then in CDDL files, here the most human readable way of possible, we can we can read about the whole things and what would be the stuff. And sure, for all of these, we have something related to protocol parameters as well, which I'm going to talk about it. And let's see, actually here we should have, I remember in Cardano node, where is it? Cardano node, there was this, is it configuration file, I think? Yeah, configuration file, which, let's go with prod. We have all these, protocol parameters that we are going to talk. So you see that these errors has genesis, like when these things started. Like, I mean, Genesis, the word is kind of explain what does this mean. It's a starting, it's like the beginning of that era, which means like when that hard fork happen or when it's going to happen. So yeah, for example, if we go, actually, let me ask you guys, what was the first era? I forgot. Byron? Do you guys remember? Byron was the first, and then Shelley, and then Alonso, and then Conway, if I remember correctly, based on
Yes,
this.
there were yes, there were a couple eras in between, but those were the ones that required separate Genesis configs.
So if we go to one of them, well, we see that, wow, it's too much stuff happening here, and we don't know what is going on, although we can go inside it. But related to the time things that we were talking, I mean, if we just scrap, or I don't know, or remove or deduct anything else and just picking up anything time related, if we look to this very small thing, we can find something very interesting. Slot duration. Well, maybe a slot doesn't mean time. No, maybe it's a place, it's a location, thinking. But duration definitely tells you, okay, there is something related to time. So this period or something's happening. So what is this slot duration? Well, we need to talk about probably the whole block producing epoch, etc. Related to this. So, and of course, this is a starting time of this, and well, this is based on my time, but I think it's around that time, like 2022 was the time for, and this is, of course, if you know, this is the POSIX time. What is POSIX time? Uh, we have like I mean, you can go and read the story about that, but POSIX time started around, I think, in 70s. POSIX time. Uh, Starting date. Okay, it's just giving me some pause. POSIX time, yeah. So again, we can go and read the story about what is this thing? English? Where is English? Okay. Anyway, so POSIX time, yeah, I forgot this is again, it's like a genesis. It's a starting point in the time that we agreed in many computer related stuff to use. Although I've seen that it was used in other places like medicines as well. But anyway, it's this was I think the beginning of the POSIX time was around 1970. Yeah, the since 1st January of 1970, and when the clock started, it started from 0 and 1 and 2 and 3. So it's just starting to grow. It's like a number. So there is no any, minutes, hours, seconds, millisecond, nothing inside it. Kind of it's just going and increase by each seconds. Seconds or milliseconds, if I remember correctly. So Cardano used this, but in a kind of two different ways. Sometimes Cardano use POSIX times. Sometimes it use slot. And that's another thing that is going to confuse you in future, sure. And there are reasons which I remember that they talk about, and hopefully it's going to be one day. But as you saw here, we have POSIX time, and here we have slot duration, which probably it is 20 seconds, if I'm right, 20,000 milliseconds or 20 seconds, which if we look into the later era, like let's say the current era, like Conway, you see that there are a lot of stuff, but I'm going to tell you what is this. Like we you remember we talked about we added an agenda cost model. Don't worry, we'll talk about it, but let's see that can we find that a slot duration here?
I think they should be in the Shelly Genesis.
Shell, still we are using that shell, right? Which become slot length is 1. Does this mean 1 second now?
Yeah, it's 1 second.
Okay. So you see that like just looking at this, there is this Genesis here with bunch of stuff inside it, and there is this another Genesis here, bunch of started. Well, again, there is not that much of compatibility, right? Like, sure, there are something similar, great, but like, yeah, we have this slot length here, and we don't have a slot. Like, yeah, we have a slot duration. Some maybe max TX size, and probably would be here as well. Yes, we have. So in that era, which was the beginning, we only wanted to just have 4 kilobyte as a TX, like each transaction, like how much they could have information or data inside it. And then we later added, and because of all this adding, now we have in the, for example, there is this Cardano node, we need to have better hardware. So yeah, this is it. And then I don't know exactly what is this, to be honest. Slot per KES period, but
Yeah, that's how many slots there are before a node is required to update its operational certificate. That's the test rotation period, and that's part of block validation. So when you get to doing the consensus and block validation and all that sort of stuff, there's a whole lot of additional things aside from the transaction side. So that's used, for validating. As you were talking about time, who gets to make a block, right? It also determines whether or not, they've passed the rules, and that's essentially the rotation rule.
I see.
Rotation. So,
but Chris, if we want to go about talking about the epochs and block producing or somewhere, do you think here's the best place to go through, or do you know any other place that we can get better information, at least something more developer friendly? I mean, for the people that for the first time they are seeing this.
There's absolutely nothing more developer friendly, unfortunately. There's no better representation of this. I mean, like, we can go look at it in Go if you want to go do that instead.
This is great. Being able to read this is essential, right? Like people need to that's an unruly file to see for the first time. But Mix, I think that was a really good tour that you just gave us.
Yeah.
Like find your way
So
around.
if you go into Goroboros,
sure. Actually, I wanted to go with Apollo. I remember that protocol parameters variable Eduardo was writing, but
right, but that doesn't have anything to do with Eras, which is why we're not good
it doesn't.
at that, right? So if you go check out Ledger and you look, we actually have the per era protocol parameters under Ledger. So all of our stuff is broken down by era. Right. So, like go look at Byron or Shelley or any of those, and we can kind of take a look at what it looks like. So the Genesis is actually even separate in our case. So
let's go with Byron.
Sure. So this is going to be the implementation of everything else. Right. So, there's first era. And there's a couple other things here. So first off, we have a default Byron slots per epoch that probably needs to change because it's a constant. Anyway, the truth is there's not been a Byron network that is not that setting, so we just didn't care.
Yeah.
Anyway,
Yeah.
keep going. You'll see. So we register the era. I mean, like that doesn't matter, but you can get into seeing this is the actual space, sorry, shape of the block header, right, in the Byron era. So if you're looking at a block, oh, you're never going to be able to fit all these on a single screen. So I would decrease it.
So yeah,
I would go back to making it bigger. Yeah, for sure.
I try
Uh,
that.
yeah, no. So all of these shapes, this was the thing we were talking about the eras and about how they're important, is most of these shapes change at an era. So that's why we have a Byron block header, and then you have a Shelley block header, and like every single one of the eras end up having this a different shape that fits the same part of the chain. So anyway, if you scroll way down in here somewhere, there's the Genesis config
Genesis config, Genesis Byron
transaction.
transaction,
Yeah, keep
type
going.
hash, inputs, outputs, feed, TTL, validated reference, collateral, withdraw.
Interface has has a big surface now. Keep going.
Uh,
Keep going.
decode generic Genesis.
Yeah, ESIS.
Well, probably. Never mind. Let's go down. Fee, collateral.
Yeah. So yeah, there you go. Protocol parameter updates gives you like
Yeah, that's it here. Yeah.
Yeah, that gives you an idea of the shape. We actually have reading from the configs. Give me a second. Let me figure out where the heck that is. I thought it was it was right here. Maybe it is. Oh, I bet you. Hey, you keep wanting to look at Dingo. I bet you.
Did you cut
Yeah.
the?
Yeah. So we actually read the node config. Oh no, that's the Cardano node config. Oh, let's see. So yeah, we read the config files in Dingo, but we create Byron Genesis types. So how do we create a Byron Genesis type? That's what I thought. Byron. All right. So there's got to be a Genesis. It's called the name of the type.
Maybe we should look into the genesis.co here.
What?
Genesis.co. Byron
Yes.
Genesis.
Yes. That was why you're not finding this stuff.
Yeah.
Is yeah, exactly. It's
Was
here.
it
So
another file?
yeah. So this
Uh,
was the stuff that was in that Byron Genesis file. This is what's in it. This is what's in the JSON. And as you scroll through the objects, you'll be able to see how they kind of break down. So in here, you get stuff like the slot duration, right? The maximum transaction size, the maximum header size, block size, right? Like all of those things that can be used for the various validations.
so Goroboros get this file, get this JSON, and then unmarshal or deserialize it into its object, or no? It just like
No, Goroboros doesn't. Goroboros does not care about that whatsoever. It just provides the object. We actually have a Cardano node reader over in Dingo, which it has a function which new Cardano node config from reader and new Cardano node config from file. And those return a Cardano node config, which has which loads the Genesis configs. So we read the Cardano config, then we load the Genesis configs that are mentioned in the Cardano config, right? And we process each one of them. So we go and we process through each one of them. But all of them are actually calling the underlying Goroboros functions. So in the Byron, there's a new Byron Genesis from file function in here. So, if you scroll down, you can see where we create that. It's probably at the bottom because it's not. Yeah, there we go. Boom.
Okay,
Right.
here.
So you see, we open a reader and then we run the new Byron Genesis from reader. New Byron Genesis from reader should be right above it. Yeah.
Yep.
And so you see, we just JSON decode. We have our own decoder. We create our own decoder so that we disallow unknown fields, which means it'll crash if there's anything in the JSON, or fail to decode if there's anything in the JSON that's unrecognized. And we just decode the JSON directly into that Byron Genesis object that you can see up above.
I saw something else actually. I wonder. I mean, I genuinely don't know. What are Genesis UTXO, AVVM UTXOs? Like, I saw there is something here. I think maybe these are the things that, or we call it like Genesis UTXO or something.
Yes. So a lot of this stuff here is where the first money went, right? So when you generate like a config, you can you specify the initial pots essentially, right?
Like minting the ADA, let's say. Right?
Yes.
Am I right?
Yes, that's basically it. So how much goes into the treasury, how much goes into the reserves, how much goes where, what's right, like starts off, and all of this is here in the Byron Genesis.
See, that's interesting.
Right.
And then once we get that, we create all the other blocks after
so it
those
creates the-
UTXOs.
Yes. Yeah. So we do have code to actually read this config. This is again, there's a lot of stuff going into Dingo that isn't ready yet, and this is where we're spending most of our time in Dingo. Is not on the client facing interfaces, but on the actual underlying stuff of processing the chain. So currently what we've been working on is this stuff, exactly that. So we're able to read that JSON file and generate the initial set, exactly this that you see, this Genesis UTXOs. So we're reading that file and generating these Genesis UTXOs, which means we're generating essentially the first block without there being a block. Right. So the starting point, because all transactions require inputs, right? This generates those first set of, like spontaneously spawned outputs, right? That are now usable, those first UTXOs.
And those first UTXO didn't have any input, right? They are just output.
Right.
They just suddenly they came to existence out of nowhere.
Out of math.
Oh, math.
From the Byron Genesis file, you go through and you run a process, and that generates UTXOs in these specific accounts, right? I mean, it's
these are wallets
explicit.
or accounts or something like that.
It's in specific wallets.
That's these are the balance. Most of them get 0. Someone got, is it 30 billion ADA? Like if we just
so
that's right.
That would be the initial 30 billion. That was essentially the first mint.
Yeah, first mint.
Right.
That
was how it started.
So for the timing, of these UTXOs, are they important? Like, for example, let's say I am a developer and I don't want to go through the really depth of the protocols of Cardano. Do I still need to know these things or no? I just need to know my current era stuff, like how these things works, what are the parameters, or no?
Yes,
I have to go and start from the beginning till today.
To calculate them, yes, because a lot of these things do carry over. The only thing that actually carries over from Byron to the current time is funds.
Just
Every single number that you're going to see here is also in Shelley. So the Shelley config also has the same things, all of the protocol parameters, max TX, right? Like all of that stuff. We talk about the Byron reboot in a lot of ways, and it's because the chain did completely change. So if you look at Shelley's config, it duplicates a lot of Byron's, is basically my point. Whereas most of the other Genesis files don't duplicate stuff, they only add new.
yeah.
So if you look at like Conway's, for example, it's just new stuff, right? Like, I mean,
Yeah,
you look at it, it's all committee, DREP, right? Like there's no, there's nothing there that isn't
like there is nothing like this. Like
duplicated, right. There's no duplication. Yeah.
and
So
also
anyway,
a supply has changed. Like supply changed from 30 billion to 45 billion, if I'm right.
Well, there
Right?
was the initial supply and then what we're working on,
yes,
right?
yes, there was the initial supply, and then this sets the max in Shelley. Again, a lot of the stuff was duplicated because the Byron to Shelley hard fork was a really, really big change. That's the easiest way to put it. Whereas most of the ones since then have been additive. They've made changes, but like they've not been like a complete rewrite. They've just been additive, or and like, oh well, this might be a little better this new way to accommodate this new feature, right? But it's not been a complete reset. And like I said, the only thing that really carried over from Byron was the
Just these,
the funds.
yeah, Genesis stuff.
Right. Yeah, the money that people still had in the system. So, you see things, and we talk about the time, but like scroll down back down to the bottom of this guy, and you see system start time. Right. That is the time of the start of
The era,
the era.
the shell era.
Yeah.
And they, I mean, in the Byron, it was in POSIX
It
time,
also
and
has
then
one. Yep.
changed it
Yeah,
to this.
yeah. Of course. Why not?
Okay. I see Emmanuel. Yes, Emmanuel, what do you think?
Yeah, I was about to ask, yes, this is Goroboros, a Cardano node, which uses Go language. And I'm also seeing, because, yes, I see something, I think TX5 teams, they are building on something like Rust, Cardano node. Not really sure, but I'm just trying to, I'm thinking, how does all of this fits to the current Plutus Haskell Cardano node. We are using how do they sync to each other and working together, and uh Go Roboros right now, is it still something like a simulation, or you can create smart contract on it with Go language, or so yes.
Goroboros is not the one that you create a smart contract. Goroboros, you see, these are, I mean, if I simplify it, I mean, I'm going to simplify it really roughly, to be honest. Let's say that we want to create this blockchain. And what the hell is this blockchain means that there are these packet of data are connected to each other, aka linked list. It's a simplified, or I mean, maybe glorified linked lists. They are all connected to each other. So now, how do we create these linked lists? How do we pack data inside there, or aka transaction inside there, which later we put this smart contract inside there, validation, everything. All these are the packages, these are the boxes. So these are the config. These are the, I mean, as you can see, these are the information helping us to create that, which here Chris was talking. And in order to create that package, that box, you need to have these nice written, headers and rules you have to follow. So Goroboros basically is a package producer. It's the one that generate those boxes and put the data inside these boxes we call it block, in the correct format. And by correct format, I mean the one which is compatible with Cardano node, or Cardano node is compatible with those packages, so that it can read it, understand it, and verify it. That these, you see that there is confirmation happening. And then again, the Ouroboros is the code, which is Cardano ledger. So we have this Cardano ledger, all these rules, all sort of things for, again, creating those boxes so that we can put the stuff inside it. But TX5 wanted to create this Cardano ledger with Rust. Blake Lab decided with Go. At the beginning, actually right now, IOG, or in that time IOHK, wanted to build this with Haskell because of all the deterministic stuff and advantage of Haskell over other languages. So Ouroboros is just that. It's like a Cardano ledger in the code, so that it creates block. And what would be those block? Well, based on this configuration. So now you have these blocks. Great. Now you need to feed that. You need to feed data. You need to give a transaction to this. You need to fill these boxes or blocks. How do you do that? You can do it with Cardano nodes. Okay, now your Cardano nodes needs, again, data. Like, okay, validation. What should a Cardano node validate? A transaction. How you can do that? Like, how we can create those transactions based on all these rules that I just said. That you need, for example, Apollo or Mesh or Atlas. These are a transaction building library. For example, in TX pipe, Dolos is the node. So TX5, Dolos on GitHub is the node. So this is the node, and the node is verifying, and it's just doing all this validation, confirmation of those blocks which was created. It's like it's based on those rules. And then you need to build those transactions so that your Cardano node put them in that box and give that box to something like Ouroboros. What would be for, is it Palace?
Yeah, Palace is probably the closest thing to
building transaction.
No, building transactions. No, not at all.
This is a build like a Ouroboros, like similar kind.
Yeah. They do have a primitive transaction builder in there, but it's very, very low level. Like, it's not.
Do they have any dedicated library for? I don't know. I
For
don't
transaction
remember.
building? No.
Transaction building like Apollo.
No.
What about Blaze?
Right,
Blaze?
but Blaze is TypeScript front end. That's not TX pipe.
Okay.
Actually, let's look at what I don't know. Blaze or no? GitHub. Let's see. Is it this guy?
Yeah.
Okay, the hottest transaction building library for Cardano. Yeah. So, well, I don't know about the hottest. We should judge that later. Comparing Apollo. Apollo has good body. Anyway, the Blaze is exactly safety. So you create this transaction, you build this transaction. Your smart contract comes here. Your smart contract validation, all the rules, input, output, UTXO, all the financial stuff happen here by Blaze, by Apollo, by Atlas, by anyone. And then you give this, and you assume, these library assume that this is a valid, okay, all following again CDDL, which we can here see it, that those transactions cannot be, for whatever, their transaction needs to follow a CBOR rule. And again, the CDDL is really where is it exactly? It was
Hey, Mix.
determined. Yep.
Can you just back up a second? You keep throwing out words like CBOR, CDDL, things like that without like any explanation whatsoever. So
Okay.
it's
Sure.
so I
So,
think let's try to stick to a language and try to stick to things in the frame of Go, right? And so we can go back and look at again the Genesis configs in Go and explain the purposes of them and not bounce over the entire ecosystem. But to answer the question that was asked, Goroboros has absolutely nothing to do with writing smart contracts. There's nothing for creating Go code that compiles down to code that is executed as a smart contract. Nobody is working on that as far as I know. We are working on a Plutus VM, which will be for executing them in the context of a node, but not for compiling them from Go code into the smart contract language.
Okay. Yes. Yes.
Yeah.
Thanks.
So Goroboros's primary thing is to provide primitives that are used at the protocol layer. So all of the main communications and all of the shapes of all of those communications and all of those things are being built into there. Into our ledger section, that is basically the equivalent of Cardano ledger. We were looking at the Haskell Cardano ledger stuff. Ours is essentially, and the CDDL files. Our implementation is in Goroboros under ledger. So you'll see it fairly well matches the same kind of layout to where we've got different eras and all of that sort of stuff, which essentially matches up. The main point that we were trying to stick to was time. Mix. Right. Yeah.
I wanted to go through the answer for
I know, but
sure. So times.
So the point is you could see in those Genesis files, it had things like the amount of time per slot, right? Like a slot duration, and that sort of stuff. And they've changed even what they meant, like here, our slot length here. This is in seconds, and in Byron it was in milliseconds. Byron slots were the same size as were the same length as blocks, and they were regular, meaning it's back at the Conway. Conway doesn't have any time.
So I just want to check with Shelly then or Alonso. Oh, we have.
There's
Shelly
no time in Alonso either. There's no time.
Okay.
Yep.
So
the only two that
the
affect
only time are the Byron and the Shelly.
Yes. And so in Byron, your slot time and your block time are the same. They're 20 seconds. And because things work differently. Like I said, there was a complete reset. So in Byron, it was just 20 seconds and 20 seconds. In Shelley, that started on average 20 seconds block time because there's some randomness in it for reasons that don't necessarily matter here. But the point is chain time is not 100% a clock time. They don't equate to each other, but slots do equate to clock time. So a slot length is measured in seconds. And so this is saying, that we have a counter of a 1 second slot time.
But Chris, I actually was trying to look into the epochs. Like, does epoch related to a slot or no? They don't have any relationship.
It is actually slots, not seconds. So it's not time.
This is not the seconds. It's the number of slots.
It
doesn't matter. Let's say the slot was like 10 seconds or 20 minutes. This is the numbers. It's not okay. See.
Correct. It is the number of slots, not the actual number of seconds.
And would you please give me your definition of epoch? Like, if you want to kind of simplify it, I can give, but maybe I kind of get off-road. What is epoch? Why do we need epoch in Cardano?
I mean, now or in the past?
Well,
Anyway,
let's
go ahead.
go for. Well, I can't say. I mean, this is my definition, but sure, everyone, you especially correct me. My definition is why we need epoch is because of the whole staking part of the Cardano. Because we are not proof of work blockchain, we are proof of stake. And the core fundamental of this blockchain is distribution of these rewards for staking. We need a time period to calculate these stakes so that we don't get these attacks. You guys can go and read about it and check about those civil attacks, network attacks, getting the 51% of the whole fund, that fund, or the number of nodes, validation, etc., like all those blockchain. So we need a staking distribution, and I don't know exactly why it was chosen as a 5 days or this number to be exact. The number of a slot, and here a slot is 1 second, by the way, initially. But this is for securing epoch existence, is for securing network integrity and a way for distribution of the rewards to the stakeholders. So is it correct?
Yes, it's also the smallest unit of rule change, essentially. Right. So not only do the rewards happen, but if there's votes or any kind of protocol parameter updates or any kind of things like that, this is the epoch length is the minimum length of time before these things can take effect. So there are certain things in consensus that say, oh, this takes 2 epochs, right? So that epoch length determines how long those things are. So the staking period, how long it takes for stake to activate, how long it takes for pools to retire, right? Like, so it's a unit of time. Like I kind of like to break it down and think of things, as like it's almost like the idea of like a month in my mind, right? Like of a pay period, essentially. And it's like the rules could
Oh,
change.
I
Your
like
rent can
that.
go up. Your
Yeah.
rent can go up month to month, or you get paid every month, right?
Yeah,
Do not
exactly.
pass go, collect $200, whatever, right? It's essentially that kind of a period of it's your one rotation of whatever you want to make that out to be in your mind, but it's like the one rotation of time.
And I should say that, I mean, based on my understanding, it's happening like a snapshot, right? That you can do whatever you want under these 432,000 seconds, but once it's reached to exact these seconds, anything that you've done now is going to be kind of recorded. It's like a snapshot. So it's not like all the things matter in that epoch. The thing which is matter is what happening at this last second. Am I right? Like what we care should be the last second of epoch, not what is happening during the epoch. Like for example, for a staking reward, I mean, my understanding comes from this. You can send your ADA to whoever, to yourself, to someone. It doesn't change your potential rewards for those staking. But when that epoch is going to change, which is in a snapshot, which is like once this 432,000, like let's say 431,999 is going to just be added with 1, that last second is the one matters because it's going to snapshot, it's going to record everything on the current state of blockchain, and then that's it. then the clock restarted and start from zero. Am I right? Is this the thing that we can do whatever in during the epoch, but we should finish everything before the epoch ends? No, like this is again maybe some misunderstanding. But from
No, the epoch, it really does not necessarily indicate a processing time period. It's more like the cliff. So part of the thing is if we well, it would be very poor performance to do things like try to calculate everything as soon as the epoch rolls over, right?
yeah, yeah.
As a chain grows, it becomes terrible, all that sort of stuff. So most of these calculations are spread out over an epoch, and there's a reason why there's delay in stuff like staking, and it's because it allows time to calculate them over the course of an epoch and have them available before the next epoch when they take effect. Right. So the point is everything is already calculated, and you already know all the answers, essentially, right? And then that epoch cliff is the cutoff point. So when you talk about snapshots, it is a snapshot time, but it's not like you process the snapshot after that. That's when the cliff is for the next calculation period. So it's not the current calculation period, it's the next one. So when we do calculations, we actually do like multiple epochs at a time. So you do your current epoch and the future epoch, and they matter for different reasons. But the point is that delay is there to prevent this problem from happening.
I see. Yeah, yeah. And regards for the staking reward, if you guys saw in your wallet, especially in Eternal, you can see that there is these 2 epoch at least. It's like your stake is lost or calculated. One is called pending. Another is called something like calculating, something like that. It's like exactly 2 epoch, I think, is the room it was given for calculation reward, but for other things. But something I just saw it as well. There is this active slot coefficient. If I think,
Yeah.
what is it? Do you know what is it?
Yeah, that's what basically says a slot is approximately every 20 seconds. That's actually a percentage of time, so it's 5%. So it's basically saying that 5% of the time, meaning 5% of a slot is maybe that slot will be the one that has a block in it, and so that's how it's basically a multiplier. Sorry, that was the word I was looking for. It's basically a multiplier in there. So basically it's saying, 1 out of every 20, because it's 5%, right? 1 out of every 20 times, we want it to be the active slot, meaning that's the slot that a block will show up in. Yeah, so that's what that active slots coefficient is. So you'll also see people talk about things like chain density, and when we talk about density, what they mean is the like amount of blocks on that fork of a chain or whatever, and the optimal chain density is this same 5%.
So if we want to kind of say, I mean, in the layman terms, if we want to have faster block producing or faster blockchain or something, should we increase this coefficient now? Like if we want to go with faster TPS or something, or no, it doesn't have any relation.
Yes. So it would, yes. So again, this is once every 5 times. If you wanted it to happen if you wanted a slot every second, then you change it to 1.0. Right. Now you got a slot every second. And in fact, I posted real quick over into the into the chat. I posted a config that we have. We have a DevNet config, and we copied it from Hydra. So it's not like anything that we came up with, but it's a super, super fast network. It runs extremely fast. And so you can see slot length is 1/10 of a second. Right. The epoch length is it's an epoch every half a second.
Half a second. Wow.
Yeah. An epoch every half a second. It's a block every every 1/10 of a second it generates a block. This is a super fast network, right? And the point is and if you look, there's only there's 2 sets of funds, like all of these things that go through here. There's also a Byron config, but you can see that this is designed for just running fast. right? And it's also built with a single block producer. So like there's only the one thing on the network.
Produce this. There is no nodes running all these things
Correct, correct.
simultaneously.
Yeah. So we use this for building ephemeral devnets. But the point is it's super fast. By changing those things.
So basically, the private testnet that we use for testing, we can change these, and we can kind of say the sidechain. The whole idea of sidechain is basically another Cardano blockchain, but with different times and different parameters. And then just the project needs to figure out how to bring the data from that faster or cheaper blockchain to the a slower mainnet. That's great. But I wonder a blockchain with this really fast spec will grow like after I don't know a week or something. How much is it? Like is it 10 gigabyte, terabyte or something?
Oh, this no, it's a lot real fast.
Really? So
Yeah.
So
Yeah.
having the really fast network needs really big resources as well.
Yes. In fact, that's one of the conversations around Laos and scaling is, like what are the additional disk requirements, right? So
we can be fast, but the problem is resources. The Cardano can be faster than who knows Solana, but the resources. Great.
Yeah.
So let's go back to the agenda. What we covered. So the time. So I think we covered like
I think we
how
got
does
it.
we got it. What is error? We think we got it. How does it rotate? Well, we got it, I think. What is a slot and what is block time? Did we talk specifically about the block time? Yeah, I think 20 seconds, right? The coefficient goes. And then we look into protocol parameters. Why? Because, well, the protocol parameters determine these block times, all of that, as you guys saw. And we could talk about cost model and fees, but and we talk about Genesis. I think you guys saw this Genesis stuff that the whole JSON file and the purpose of different networks. Well, I think cost model and fees might be quite complicated for themselves, but I feel that if we answer the things that, or talk about the things that are smaller to talk about, would be better. I don't know. Do you guys want to talk about other or cost model?
I think just talking about the cost model is fine. We do not need to go into any
Okay.
kind of detail of what it is. And this is really simple because cost models are really related to smart contracts. So until we start talking about and to smart contracts, we don't really care.
Yeah.
It's basically what I'm getting at. But you can go through this, and the essential thing of what the cost model is and how it plays in is each different operation, right, that you can do in a smart contract has a cost. And that's what the cost model is it's just the mapping, it's the entire map of those costs, right? So if you want to run this particular thing, it costs this much in units, execution units. So
Yeah, but one question I don't know. I have right now Plutus version 1 cost model and Plutus version 3 here cost model. Where is the Plutus version 2? Did we ever had
the
Plutus
Plutus
version?
V2 cost model.
Should be in Alonso, Genesis.
Well, I mean, this is the Shelly.
Yeah.
It
No,
is Alonso. Inside Alonso, we have Plutus version 1.
Babbage.
Oh,
It came with
Babbage.
Babbage, but
Where is Babbage? Yeah.
there's not a Genesis for Babbage. There's not a file because it wasn't necessary. We
I
updated it.
Yeah, I
for
think they have
volume.
the same cost model. Maybe.
Sure, Bluetooth version 2 having same cost model Bluetooth version 1. But I remember you said there is this Blink Lab. Where is Blink Labs protocol parameters in Gorovers? So eras,
Ledger.
ledgers, yeah. Babbage.
Yeah, no, this
Do
is
we
just
have
the
Bluetooth
wrapper. No,
version
this is just the
2?
wrapper. You need the actual Babbage under Babbage.
Okay, where is Babbage? Here. And then we have Babbage params. Let's go with the Babbage.go. Transaction type here, sure transaction. ETX RPC.
Yeah, that's for you're still on block. Keep going.
Yeah.
You got a long way to go to get to Genesis.
Put Genesis output protocol parameters reference input. Well, I should say that in Babbage we got this reference input, the UTXO, which can hold uh, datum and of course the CBOR. Not CBOR, the contracts. Let's not talk about CBOR now. We'll talk about CBOR, what there is CBOR in future. But yeah, anyway, so we should go into more depth. So the cost model, yeah, as Chris said, it's just a way for calculating the execution, like the how much it costs for evaluation of these contracts. Uh, but as you can see, as also Chris mentioned, after Shelley, these Genesis are kind of adds on, so they just complete each other. It's like they copy each other. So we have in really in details like what is these numbers means in Pultus version 1 inside the Alonso Genesis. But once we look into the where is it? Yeah, here is the Conway Genesis, the current era. We just see this bunch of numbers without any meaning behind them. But here the meaning is here. We can look into that and finding the what do we mean by those numbers. And if you want to decrease, I mean, let's say you have a I don't know some sort of again sidechain, you want to decrease the cost of a transaction for a small contract. Like for example, you have a DEX, you are going to write a DEX or something, and the transaction is expensive, and you are thinking of how can I make this transaction much cheaper? Well, in your side chain or parallel chain or I don't know whatever blockchain that you are running and stuff, you need to change these protocol parameters. You need to reduce the cost, right? It's that's logical. So by reducing these costs, basically you are reducing the cost of execution of a small contract. But a question that I have is first, I mean, this is my question first. The transaction without any smart contract, if the transaction is bigger, like I want to send 1 million ADA with 50 different tokens, that transaction is more expensive than the other transaction. So the calculation of that transaction, again, there is no smart contract inside that transaction. It's just the size, like because the size is more or it's bigger, that's why the fee for that transaction is bigger. Or no, there is some sort of evaluation happening besides the size as well. Does anyone know? Do you know, Chris, about this question? Like if
I'm
a
sorry.
transaction without a smart contract inside it is
Yeah.
big, like I'm sending 1 million with 50 different tokens to you, that transaction fee is higher than a normal transaction. Like if I just want to send 1,000 ADA to you without any token.
Sure.
The difference of this fee is just because of the size of the transaction, or no, there are some sort of validation happen as well. Like I don't know, some other stuff besides the size.
For a transaction? No.
For a
For a
big
single transaction?
transaction.
No.
So the only things matter in a transaction without a smart contract is just the size.
It's just the size, yes.
It's just the size.
Yes, you can find it under main, no, fee A and fee B or something.
Where?
Yeah.
Which Genesis?
It should be in Shelly.
Alonso Shelley.
Yeah, it's the min fee A
Min
and
fee
min
B
B. And then there's these are basically the rules that apply: the max TX size, the block body size, block header size, right? Min fee A. So obviously the block ones don't apply to a transaction, but they do apply if it comes to transaction propagation, right? Like we're not going to ask for a transaction that would make it bigger than the block body size, than the max block body size if I'm trying to build a block, right? So when it comes to node communication.
So I can kind of say that unlike Ethereum or any account-based blockchain, time does not have any influence on the transaction fee. The only
Right.
influence is just the size, which is, I think, is the advantage. So there is no any relationship of time and the fee.
How
Sorry
is
again?
it in Ethereum?
In Ethereum, well, the time matters. Like if you want to, for example, if you want to submit your transaction sooner, by paying more fee, your transaction there are these tools called MEV, maximum extraction value. There are the bots.
So it's like
Pick up.
with Bitcoin. If you pay more, you get
Yes.
faster canonization.
So
Yeah,
the
I think
time matters in
the
them.
input
Or the fee.
output has research currently. They're researching to have something similar, but differentiating between two types of transactions, fast and slow.
Norm.
And in the fast, you would have the same pattern where you pay more and then your transaction is faster submitted.
Is it just in the research state or no? They're going to
I
implement it. I don't
think
know.
it's in research state.
So, by the way, there is really great conversation happening inside the chat regards to the cost model and many other stuff. Sorry, I'm not really following up in the chat because
We've got you, Prof. Yep.
yeah, but it's really great conversation happening, and you can continue your conversation. Of course, Gimbalab channels in here. And I just want to say about this person. The person needs first Dingo and of course Adder, in my opinion, for what the things he wants to build. But regards to time and protocol parameters, there are many other things that we need to cover. We need to discuss. It's not really an easy concept, to be honest. I mean, for myself, I can say I've been in this economy or this ecosystem for a couple of years. There are still questions, and the thing is, these especially this blockchain and this environment change really rapidly. Like it's just another Genesis might come and it's totally different things. And here is kind of like inside this Cardano thing. We did this in Haskell. That's your problem if you want to do it in any other language. So this mindset kind of create again this situation that we every time for I don't know for how long, but at least for the next 5 years, have to learn new things So it's not like you learn something and it would be done. No, sure, the history helps, absolutely. Like, it helped me today. I hope it helped you as well. But things are going to change. These are happening. Like, yeah, we had this thing in the past. It was 20 seconds. Now it's 1 second. And inside the smart contract, things are a little bit different. But hopefully, the discussion that we had about all these topics was beneficial. Well, next week, actually, we can pick up in different topics. And of course, this is really important issue, this race condition.
Can we keep using this process? I think starting with agenda setting, and sometimes we can use previous agenda items, but somebody might show up next week with a different topic they really want to talk.
Yeah.
So we can
And
start
if you-
every session this way. And you guys,
Yeah.
Mix and Chris, thank you for that conversation. I learned a lot, and really good.
I
to
really
go
appreciate
the back and
Chris.
forth.
And I hope, Chris, you write a book in near future, about your experience in Cardano and all these things. You have a great stories. Like, we can sit around the fire and Cardano nights with Chris. And
Oh, yeah, I bet. Usually involves, like sitting at Seaboard.me and crying. But
but really looking into this genesis, like, imagine Chris coming to Cardano for the first day, like the first hour, and looking, what the hell is this thing?
It would just be breaking.
Wow.
yeah, and that's the thing, was our first coming here was to run a stake pool. So one of the very first things we had to do was use the CLI to query all of these random things from a node that we got running, and then calculate and create like command line calculations of fees, by collecting UTXOs and calculating their sizes and multiplying them, and like doing all this kind of stuff. And we're like, this is crazy.
Yeah, things were really, really, really bad. I mean, it wasn't really that much bad, but it was really developer things that people had to do. Right?
But a dev saying this is crazy is the first step always, right? You have to see a situation, say that, and say, oh, I could do it better.
So I just got to tell you, that's exactly how Goroboros came about.
Yeah,
this is crazy. I can do this.
Make the genius people frustrated. You are going to get a better world.
Right,
yes, Scott.
Oh yeah, jump to Scott. Yep.
Hey, I just want to let y'all know that, like, I hopped in late, but this space was awesome. I appreciate y'all.
Great, thank you.
Getting down to the basics and stuff like that. And Chris, I appreciate you answering the questions in the chat, and you too, James. So I hope we have more spaces like this, because this was just fabulous.
Sure, thank you, Scott. Sure, for whoever is watching later, please join us if you have question, or if you want to get some question and then start to answering these questions, like the people like Chris. You're most welcome here. And again, thank you, Chris, and thank you, James, and thank you everyone for being here. Great discussion. Hopefully see you next week. And again, if you want to touch with any of the members here, feel free to start a conversation in Gimbalabs channel. Thank you. Have a great day and night. Enjoy your frustration, because, well, your frustration and your solution makes other people's lives better. We appreciate that.
Well said.
Great,
See you soon, everybody. Thank you.
Take care.
Bye.